No, I don't have.
Okay, Vasan, you're good?
Yes.
Okay, awesome. Then, without any further delay, let's start with today's session. I will give me 2 minutes. I will share my iPad screen. Okay, you guys can see my screen.
Yes. Yes, able to see that.
Okay, so today's topic, as we have discussed, is deep learning. Uh, So why we need to learn deep learning, right? Why machine learning was not sufficient for everything? I mean, why doesn't it solve every problem that we have? Why is deep learning essential? The first point is that. The next point is how is deep learning different from machine learning? I mean, what are its pros or what are its advanced complexities that helps deep learning to solve problems which machine learning could not do? Okay, so as you can see, artificial intelligence is a very big thing, right? So, for example, even in automation, a simple macro which makes your life easier, make automates it, I can call that under artificial intelligence. Okay, so artificial intelligence is a very big circle. Okay, it involves a lot of things. Then we see machine learning. How machine learning has evolved is like how we can have the data, use my machine to get learn the past historicals and learn the past patterns, and based on that I can predict. Okay, so that is something that machine learning enables you to do. Deep learning is further subset of machine learning. Okay, so many people have this confusion that deep learning is much bigger than artificial intelligence. No, deep learning is a subset of artificial intelligence. It is a subset of machine learning. So deep learning helps you to solve more niche problems. Okay, so some things which machine learning cannot do, deep learning does. However, something which machine learning can do, deep learning also can do. Okay, so deep learning is more powerful. It's more, let's say, uh, it's more ambidextrous compared to machine learning, right? Machine learning can solve a limited set of problems. So machine learning does very good on structured data. So if your data is, as I told, in form of an Excel sheet, machine learning is well suited for that. Okay, so why? So Sunil had this question: why you don't want to go into deep learning directly? Why you don't want to go to deep learning directly? One, again, from the beginning, you have to think that you don't know God's function. So God may be using a very simple function to generate the data. So going to deep learning will not help. So you should always start with simpler models and then go to deep learning. One, a single point. Second, deep learning always works always works good on when you have lots of data. If you have just 30 points or 100 points or 1000 points, deep learning will not help. Why it will not help, we will try to understand that. But so machine learning and deep learning, so if I can make some distinctions, needs moderate amount of data. Deep learning needs a lot of data, works on structured data, works on both structured and unstructured data. Okay, so deep learning is more, as I said, ambidextrous. It can operate on both structured data and unstructured data. Okay, let us see what are the limitations of machine learning. Let's say if you have a lot of dimensions in the data. So for example, if you have, let's say we have seen till now 10 or 12 dimension mean features. Okay, so let's say you have a lot of features, 1,000 features you have, right? And it is not possible for you to extract features from that. Okay, so machine learning will fail in cases where you have a lot of dimensions. So machine learning will not be able to understand the patterns in the dimensions. Another problem is where you don't have features, like for example natural language processing. You're kind of generating words as numbers, but those are not actual features. It is something like that the user is generating, right? Those are not actual features. Those are something which I have generated from the data, right? So maybe they are good, maybe they are not very good, maybe they are absolutely bad. So features, when someone gives you an Excel sheet, you have those features ready, right? So income is there, age is there, your let's say occupation is there, income is there, height is there, weight is there. So someone has given you all the features. What if someone has given you just an Excel sheet, doesn't have the features, has not given you features, and let's say even, okay, now let's take an example. Suppose you want to predict that whether there will be rain tomorrow. Okay, so for example, someone has given you whether what is the wind velocity, what is the temperature, where you are located, what are the possible high tide and low tide timings. All of this they have given, okay, but they have forgotten to give you humidity. So whatever you do, you'll not be able to extract the feature called humidity from these things, right? I think, did you guys lose my screen?
Yeah. Yes.
Yeah, I think. Yeah.
Yeah. Able to.
Okay. So humid. So someone has not given you humidity, right? So you machine learning will not be able to generate the feature called humidity from all these data. Deep learning can do that. How it can do that, we will see. The other limitation is, for example, there's an image. Okay, now image, as I told you, is a matrix, is a three-dimensional matrix where you have the pixels of red, blue, green. Okay, that's it. It is a three-dimensional matrix which has the pixels density of these three colors. Has anyone come up to you and said that, okay, this picture has, let's say it's a picture of a car, so has anyone told you, okay, the picture features are four wheels are there, they are black, they are the color of the car is red, there are two headlights? No one has come and told you what are the features, right? You have to be intelligent enough, your algorithm has to be intelligent enough that it can extract the features from the image. That machine learning cannot do. Okay, so understand this. Why machine learning fails in such scenarios? Because you have not told the machine learning algorithm that these are the specific features as we used to give initially. Right now what you have given is a set of numbers or a set of words. Okay, and you're asking that algorithm to predict. So you're leaving the feature generation to the algorithm and asking him to devise its own features, right? That is a challenge for machine learning. However, deep learning can do. So, um, okay, now if you have understood this, let's see how what are the general deep learning usages. Now, for example, you have a image of a cat. Okay, this image of a cat, as I told you, is represented in a three-dimensional matrix. Okay, now what it is doing is it is extracting features from these matrices and kind of trying to collaborate. Okay, so what it's doing is kind of collaborating different parts of the image. Okay, so it is taking these parts, and you see such kind of a filter. This is called a filter. So using this filter, it is kind of narrowing down to features. Okay, so it is narrowing, extracting information from the original matrix, and it is narrowing down. It will narrow down to, let's say, the number of categories of the data. For example, you just had cat and dog in your database, and you want to predict whether the image is of a cat and a dog. So from the initial image, the C1, it is trying to extract information in steps and kind of ending up in a two-dimensional matrix where it will say whether it is a cat or whether it is a dog. Okay, how it is doing we will see slowly, but understand this thing. Here you have not told that the image has four legs, whether it has feather, whether it has two eyes, whether it has tail or not. Okay, you have just given the image to the algorithm. The algorithm is smart enough to extract information from the pixels of the data and kind of collaborating the information in steps to find out the final category. Okay, now any questions here?
No, no should be from me.
Okay, so Neil.
No question.
Okay, so just forget this left side, whatever the architecture is. Just understand how, what is the power of deep learning. See, if you can see on the right hand side, given an image, the deep learning can tell you where is the light on the wall, where are people in the background, where is a man sitting on the table, man with black hair, man wearing blue jeans. Everything it can automatically tell from the image. You so for example in Facebook, right? When you put up a photo, many a times it automatically tells you whether you want to tag this person or not. How does it do it? It uses the same phenomena of deep learning. What it does is it recognizes your images and it sees that what are the who are the possible people in your in your photos that you have posted in historically, and based on that it identifies the structure of that person from the image and tells you that a suggestion that this person want to tag this person. And many 99% it is correct, right? It tells you the that do you want to tag this and this fellow in your photo. So if from an no one did you ever tell Facebook that my friend who is like 6 feet tall, wears black t-shirt, wears blue jeans, wears these shoes, this guy is my let's say this guy is Sharad for me. Did you ever tell Facebook that? No, right? You have never told Facebook the features of Sharad. Sharad is automatically being understood by Facebook through his image. Okay, so Sunil might have posted so many pictures with Sharad on Facebook. Now, if he posts a new photo, Facebook will see who are the probable people with whom Sunil posts the picture, and based on Sharad's contour, Facebook will tell, do you want to tag Sharad in your photo? That's how it does. So this is called caption generation, right? So whenever you see an image, you kind of derive captions. Now all these are supervised learning, right? Some or the other day, Sunil had tagged Sharad in his photo. He didn't tell, although he didn't tell how Sharad looks like, but he told Facebook that this person is Sharad by tagging him. Facebook is very intelligent, so that when after he has done, okay, just let me increase the screen. It automatically stops whenever it crosses 2 minutes. I think that's right. Just a sec.
Okay.
Just a sec. Okay. So it automatically understands that. So Sunil might have tagged Sharad in his photos prior some day. Now Facebook is very intelligent that it kind of extracts that data. Okay. Now this is a very interesting application. Suppose you have input some sequence of a story. John moved to the garden. John got the apple. John moved to the kitchen. And something, some new sentence come up. Sandra got milk there. John dropped the apple. John moved to office. Now, if you ask a question, where is the apple? It can tell you that it is in the kitchen. So this is called, it is kind of remembering things. Okay, so it has remembered that John moved to the garden, that he got the apple, then he moved to kitchen, he dropped the apple in kitchen, and then he left. There's no mention of apple in the next sentence. So based on that, it can tell you where is the apple. So if, let's say in business scenarios, like for example time series problems, right? If you want to predict what is the sales for in the next 2-3 months, right? So sales prediction is something called a memory, which is dependent on the past memory, right? So how has the sales been in the last year, this time? How the sales have been in the previous month? How the sales have of the competitor products have been? So sales forecasting is something which you can relate this to, right? So a lot of different things. So these things machine learning cannot tell you, right? Because you are not inputting features in these, you are just inputting sentences, and deep learning is itself learning the algorithms to understand what is the you know what is the sequence, what is the image. Okay. Okay. Other phenomena what deep learning can do is, for example, you enter a caption, you the small, for example, the image search in Google, right? You kind of type in your query, and based on that it also gives you images, right? It also gives us videos. How does it do that? So images, so it learns the same caption image generation from caption algorithm, where in you type your query, and from that your image will be generated, and it will give you the possible images. So this is how your deep learning can influence. Okay, so neural networks are not very new. Okay, people have been trying on hands-on neural networks since very old days. Okay, so neural networks, yeah, initially they were used for binary classification. They had a lot of hype, but then they died out in 1990s. Then back propagation, we will understand what is back propagation. Okay, then neural networks take the backseat because they, as we did support vector machines, right? We learned support vector machines. They were introduced in 1990s, and they were far more outperforming than neural networks at that point of time. Then you see this difference. Access to large datasets and more computation allow deep networks to return and have the state-of-the-art results in speech, vision, natural language processing. Okay, so as I said, deep learning can, it's awesome for unstructured data. It's good for structured data also. It can beat many machine learning algorithms, but machine learning cannot handle unstructured data. Okay, so that you have to keep in mind. Okay, now What is the difference between classical machine learning, what we have learned, and deep learning? So, for example, if let's say someone gives you an image of a car, and then you want to, tell which car it is, what you will do, you have an n cross n matrix. Let's say these are the pixels of the data, 28 cross 28. Okay. What you want to do is convert this to, let's say, 10 features, and using those 10 features you can fit all the models that we have learned, right? And then you predict the vehicle. Now, who will tell you these 10 features? Will it be you? Will it be me? Will it be some other person? No one is going to tell you. That is the problem. If someone was an expert, right? So let's say this is a Honda car. So a person from Honda knows what will be the features of its Honda car. If it is a Mercedes brand, a person from Mercedes will can tell you. But are you going to call your people from Honda or people from Mercedes? There may be maybe 20 brands. Are you going to call experts from each of the brands and ask them what are the features of their car that can be extracted from the photo? No, right? That is not what you do. You may as well do it manually, right? If you can, if you need to call so many people. So from an image, you have to design key features and then apply an algorithm. What if I said that I don't need to use any feature selection, just give me the image, I will tell you which car it is. Okay, that's the power of deep learning. So good feature selection is challenging, like what we saw in our Boston housing data set, right? So we had done a feature selection algorithm first, ingredient boosting. It gave us what are the important features. Then we run an algorithm, but we saw that how your feature importance is being generated. So every time, so for example, if you have 20 features, it is okay. If you have 1,000 features, and then it says 100 or 200 of them are important, how will you manage your algorithm? It's very difficult to manage, right? So that's where your good feature selection will fail, right? You will not able to understand which are the 200 I should take. If my limitations are less, how can I incorporate those? So that's where the deep learning comes into part. You give me the image, I will learn the pixels from the image, and no need to select features. The algorithm will do it on its own. Okay. So feature extraction is automatic. That is the biggest advantage of deep learning. Okay. Any doubts till now?
No doubt.
Are you getting the essence, or is it like a little difficult to understand?
No, basically up to this, what we have covered,
Yeah.
forget about the machine learning, the deep learning, the first task is to feature extraction, then feature reduction.
Huh.
These are the two things. So how we will do that, I think so. You will cover after this one.
Correct. Correct. Okay.
So from all this story, these are the two things we have got, that it will automatically extract the features, and also it will reduce features.
Correct. Correct. So, Vasant, any doubts from your side?
No, all good
Okay.
until now.
So, to understand deep learning, first you have to understand what are frameworks. So, frameworks are nothing but, so for example, in machine learning, you had packages. In deep learning, you have frameworks. Okay, so just put that analogy. So, in machine learning, you had these packages which were doing your calculations and just giving you an output. Deep learning cannot be done through packages, the normal packages that Python has. So you have to install some framework. So the most common framework that is used is the TensorFlow. It is from Google. So using Google's TensorFlow, what you can do is you can represent, so all these images. So like these are three-dimensional matrices, right? So all these calculations can be done much faster in TensorFlow.
Yeah, right.
Sorry,
Your voice is breaking.
my voice is breaking. Uh,
Seems maybe a network connection.
okay. Can you hear me?
Now it's better. Yeah, it's good.
Okay. Just give me 2 minutes. I think my iPad has. Okay. Guys, just give me 2 minutes. I'll just be back. Yeah, 2 minutes. Yeah. Okay, I'm back. So where we were discussing about TensorFlow. So as you just, I think the voice is echoing. You guys can hear me properly, right?
Yes.
Okay. So what we I was discussing is Google's TensorFlow is one of the most famous frameworks where you need to do deep learning, right? So in order to do deep learning, you have to install a framework. Okay, so Neon is from Intel, TensorFlow is from Google, PyTorch is from Python, I think. But all these frameworks can be installed in Python, right? So it's not that you have to learn a different language. Just the framework needs to be installed in your this thing. So how is deep learning used? It is used in video recognition, it is used in clustering, It is used in image recognition, speech recognition. More data, more accuracy. That's the simple funda of deep learning. Okay. Okay. Now it here comes the difficult part. Okay. Now I'll be very slow in making you understand these things because this is a little tough, but this is the backbone of deep learning, right? So what the like the question Sunil had, how it is helping us to generate features, we will understand from here. Okay, just bear with me and let's try to understand this slowly. Okay, so let's say there is an image. Okay, let's start with an image. So that image is 28 cross 28. These are 784 pixels. Okay, so those pixels will be fed to the data. Just understand this. So I have not told anything about sorry. So I've not told anything about features, right? So I have just given you the image. The image has pixels. So all these 784 pixels of a single image. Okay, so right now we are talking about a single row. Like you had your data frame in machine learning, your first row, second row, third row, like this. Okay, now you have first image. This image itself is a 28 cross 28. Then you have the second image. You have 28 cross 28. Third image 28 cross 28. Okay, so are you understanding this, how your data is flowing?
So you mean every xi that is equivalent
So
equivalent to an image?
when you feed in this row, first row, so this is about image 1 we are talking about. Okay, so this is image 1, and there are 784 pixels of a single image. Okay, so understand, like let's understand this. So for example, in your conventional, just I think it is, my iPad is hanging, just a sec, the other apps. Okay, so for example, uh, in your conventional data set, what you had features here and you had rows here, right? Right.
Yeah, yeah, yes.
So now what you have rows here which are images, and these are your pixels. 784 pixels are the features. So for example, when you feed in the first image, how many x will be there?
784 you mean?
Exactly. So a single image will have, now let us call those pixels as features. A single image will have 784 features.
It
Okay.
means every x is representing an pixel, right?
Yeah, 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 yeah.
Yeah.
Okay. Till now it is clear.
Yes.
Okay.
Yeah.
Let me just restart my OneNote app. I think it's a little hanging. Okay, so we have understood that there are 784 pixels, and each of these pixels are the features. Okay, so this is clear to us now. Now pay your attention to how the lines from the input layer to the hidden layer are flowing. So each pixel is flowing to the uh, other. Let's say your hidden layer has 500 features. Okay, so let's say your A1, A2, A3, A4 to A5 is, let's say, 5 till 500. Okay, now just a sec. So let's say these are till A.
Subhadeep, got two things basically. Why 500?
Yeah, I'm explaining slowly. Wait,
Okay.
let me complete, right? Otherwise, how will I explain? Let me complete. So let's say it is 500. So what you're doing is, understand this, you're combining the pixels in such a way that 784 features now can be represented into 500 features. Are you getting it? So what you have done, each of these feature, let's say this is our new feature that is being generated. This is a new feature. A1 is a new feature that is being generated. Now this new feature is taking inputs from all the 784 features. The next second feature, this is also a new feature. This is also taking inputs from all the 784 features. So what you're trying to do, you're creating new 500 new features, which are the combinations of the 784 features. So right now, let's see, for example, the earlier example that I told you. You are being given wind velocity. You are giving, now let's write it here. Okay, so now let's say you had a traditional machine learning problem. Now you had, one is wind velocity, one is temperature. Okay, one is, let's say, sun intensity. Okay, one is, let's say, tide, high tide or low tide, and the other one is, let's say, what can you say, wind velocity, temperature, sun intensity, tide, and last rainfall, whether it was 2 days back or 3 days back. Suppose you want to have, these are the features. Now let's say there are how many features? One, two, three, four, five features. Now you're creating a new data frame. Okay, you're creating a new data frame. Let's say now you want just 3 features. You don't want 5 features. You want 3 features. Now each of these 3 features is a combination of these three or these five. So your first feature, new feature generated, is a combination. Let's say wind velocity plus temperature divided by sun intensity plus tide minus rainfall. Okay, so this can be a new feature. Using the earlier 5 features, you're creating a new feature combination. Hello?
Yes.
Yeah. Okay. So
Yes.
next, the second new feature is again a combination, and let's say wind velocity into temperature plus rainfall minus tide. And the third feature is sun into tide minus rainfall. Okay, so can you see what I have done? From the initial 5 features, I've gone into new 3 features, which are a combination of the earlier 5 features. So initially you had 784 features. If you take the analogy now you're creating new 500 features out of these 784, which are a combination of the earlier 784 features. Why you doing this? Because you're doing this because this combined feature may have a representation which was not earlier present when it was independently present. So for example, humidity may be a function of these things, and humidity is a very important feature that the data frame never had initially. So humidity may be a combination of these features that you have got. Let's say this may be rainfall for tomorrow. This can be a function for that. You never know. I'm not saying that it is exactly the feature, but you never know. It is in that hope that you're trying to build a kind of a new features which takes into the consideration the earlier features and combining them into such a way that the new features are more giving you more information to your problem. Is this clear till now?
Shubdeep, I have a question that how does it generate five features to three features? Means how does it calculate those?
Correct. That I'll come to that. I'll come to that. The how part, just leave it aside. I'll come to that. How it is doing. Uh,
Okay.
right now, is the what clear? I mean, what we are doing is clear.
Yeah. Yes. Yes. Yeah.
Okay. So, Neil, for you also, it is clear what we are trying to do.
Yeah, it's clear. Basically, we are reducing the features,
Okay.
but how, that is the question I'm waiting for.
Yeah, yeah. You're not necessarily reducing. The main important part is combining the features in certain particular combinations such that it becomes more
Yeah, or
informative.
Yeah.
exactly.
Useful further.
Exactly. In another way, we are applying some function. Which function is that?
Yeah.
So based on that, we are getting some new.
Okay. So similarly, from 500 you will reduce to 200. Then you will reduce to according to the number of hidden layers. For example, I keep 5 hidden layers. So after at the fifth layer, let's say we have reduced to 50 features. From 50 features, finally, you will reduce to the number of features that your or the number of classes you want to predict. For example, you have to predict cat, dog, horse. So what it will do is slowly, slowly it will. So for example, let's take this example. So now you have three features. Now you want to predict whether there will be rainfall or not tomorrow. Okay. Suppose after you have got these three features, now you have to predict whether there will be rainfall or not. So what it will do, it will further combine these three features and get one feature which will predict yes, and the other feature which will predict no. Now how it is doing, now we will see. Okay, now let's go back to the image. So what it does is,
Shubhadeep, one question.
yeah,
Uh, yeah, basically in this, we have got Y1, Y2, or whatever output, few predictors we have got. So based on that predictor, we have to decide whether there will be tomorrow rain or not.
correct.
So it means again we have some previous data, structured data somewhere from which we will predict this new value.
Yeah, yeah. You have this structured data, right? I'm just giving you an analogy between the image and the data set, right? Right now, what we are working on images. Okay, so you have so many. Okay, let me first complete the process. Then we can answer the questions. Let me first complete this process. So
Okay.
so you have got your output here. Now, how you are doing this? So what you're doing is your A1 is something called wx1 plus wx2 plus like this w784 x784 plus bias. So A1 is a linear combination of the x1 to 784 features. Similarly, A2 is a different linear combination. So let's say W1, or let's say B1 x1 plus B2 x2 plus B3 x3, like this, B74 784 x 784 plus let's say bias. This was capital B1, this is capital B2. What it is do Now understand this very slowly. Let's see what it is doing is it is assigning the weights. For example, in neurons, how it does is it is basically assigning weights to these connections and forming A1 as a linear combination of all the 784 pixels. Similarly, A2 is a linear combination of all the x1 to 784 and forming A2. Then similarly, it will uh, calculate. Now, once you have understood this layer is again the same, right? Again from A1, it is combining A1 to A500, and it is combining through different weights, and it is calculating this. Okay. Now, how will these weights be calculated? These weights are calculated by a phenomena called backpropagation. Now, see, I agree deep learning is a little difficult, but let's try to understand. Now, let's say we have three features. Okay, x1, x2, x3. Let's learn from our simple example. So we have income, we have age, and we have, let's say, work x. Okay, and we want to predict whether he will buy a high budget house or a low budget house. That's how what we want to predict. Okay. Now let's start this uh, problem. Let me draw this properly. Let's say my there are three people. The data contains three people. The first one has an income of 2000, age of 23, work X of 5 years, budget of the house is low. One has 20,000, age is 27, work X is 2 years, budget is high. And other is, let's say, 50,000, age is 50, work X is, let's say, 20 years, and budget is high. Now you want to predict for someone who is 40,000, age is 46, and work X is 12 years. That's your objective. Now you have learned your machine learning. Okay, you have got certain accuracy. Fine. Now your boss tells, I want you to apply deep learning. I want to get a better accuracy. You say, okay, no problem. Now let's understand how your deep learning will work. Let's say, let's take the first person, your first point. Your age is what? Sorry, your income is 20,000, age is 23, and work X is 5. So let's say you want to build a deep learning network, neural network that contains two features. Okay. So this is some, let's say 22,000 W1 2000 plus W2 23 plus W3 5 plus B1. This is let's say X1 2000 plus X2 23 plus X3 5 plus B2. Okay, and then you have your output. This is your high, This is your low. Okay. Now again, this is, let's say, A1 and A2. Again, you have some weights which are, let's say, capital A, capital A2. So high is capital A, A1 plus capital A2, A2 plus bias is, let's say, M1. And this one has capital B1, A1 plus capital B2, A2, and it has a bias called M2. So what you have done is, now understand this very properly. What you have done is, instead of using these features to calculate this output, you have introduced a hidden layer in between. Okay, this is your hidden layer. This is your calculation that the model is doing. You are not doing anything. So between this, earlier your machine learning was using this input and calculating this output, right? But what you have done, you are very smart, you have done introduced something called a hidden layer. Hidden layer, what it is doing is, it is kind of combining the features in such a way that they are a linear combination of the present features. Forget this bias first. It's a linear combination of W1 2000 plus W2 23 plus W3 5. Then again, this one is X1 2000 plus X2 23 plus X3 5. Forget this by B2 for some time. Okay. Using these features, now it is predicting your high and low. What you were doing in machine learning, from this layer to this layer, you're going directly. Deep learning introduces a layer in between that, which is calculating new features based on the initial features you have. Now, how is this being calculated? That would be your next question, right? How do you say how you are calculating W1, W2, W3, X1, X2, X3, then again A1, A2, B1, B2, right? That should be your question. Now, there's something called a back propagation algorithm. Now, before we go to this, let's remember what we did for stochastic gradient. Do you guys remember stochastic gradient? How we were reducing the RMSE in linear regression? Guys, you there?
Yes, yes, sure.
Yes.
Do you remember how we were doing stochastic gradient? The water and the ball effect. Do you remember? You had this function, your water droplet was here. You wanted to achieve the minimum point.
Basically, that was related when we did, I think so, lasso and reach.
Not lasso ridge, linear regression.
At the time,
when we were
linear regression we were doing.
my y is a plus bx, and this is my predicted, and my actual y is y. So y minus y hat, we were summing up and reducing. Remember, minimizing of summation of y minus y bar. This was your cost function in
Yes.
linear regression. Remember? Come on, give me a confident yes. Remember, yes or no?
Yes.
Yeah.
Remember, right? So
Yes.
how we got a plus bx? You remember, we were differentiating and getting the value of a and bx, a and b. Okay, I think you have forgotten. So what essentially we did in linear regression, we had a predicted value. We had assumed these coefficients. Now that's why the problem is, if you don't have the basics of machine learning very strong, your deep learning will not be that useful. So you have to understand why we spend so much time in machine learning. When we had this line, we were doing, and we were reducing these distances. Based on that, we were
Yeah.
finding the A and B's of the line, right?
Yes. Yeah.
Yes.
So for that, we were using stochastic gradient, where your particular at current point you are here, you want to achieve the minimum point, so you differentiate and get the values of A and B, and that will be your best line. Remember now?
Yes. Yeah.
Correct.
Remember now. Need to find out the nearest
Yeah,
point.
the best line that passes from through the which is the
Yeah.
closest to all the points, right?
Yes.
So that was our objective. So
Yeah.
what we were doing, we were actually mathematically what we were doing, we were differentiating A and B, and then coming back to our, I mean, what we were doing, we were minimizing this function, right? Even in the cost quiz, you guys told correctly. This was the cost function, and we were reducing this cost function, right? Remember? This is the RMSE, minimization
Yes.
of the RMSE, right?
Yes. Yes.
Yes or no?
Yeah.
Yes.
Yeah, okay, perfect.
Yes.
Yes.
Yeah.
Video.
So similarly, what you are doing here is, instead of that direct linear regression where you are forming y is equal to 2000, okay, now this is a logistic regression, so it doesn't matter, but just try to understand. Let's say high is, instead of high we have 50,000, and in low we have 20,000. Okay, so you just, so that you don't get confused in between why we are predicting continuous variable. So let's say in linear regression, what you were doing, you were trying to find out 50,000 as a function of A into 2000 plus B into 23 plus C into 5 plus a constant function, constant, right? D was there, right? And then you were finding A, B, C from the data. Okay, now let me write it more, which is beta naught plus beta 1 into 2000 plus beta 2 into 23 plus beta 3 into 5. This is the linear regression equation, right or wrong?
Yes. Yes. Yeah.
Yes.
Yes, okay. So it means the, the fact that you are trying to predict 50,000 directly from these features in linear regression, in deep learning, what you're trying to do, you're trying to find out 50,000 as a function of a1. Let's say this is the same as b1. Instead of 2000, now you have a1 plus a2. Instead of b2 you have a2, and instead of 23 you have a2. Instead of these three features, you have two features with different coefficients, and these features are also derived from these things. Are you getting the point?
Yeah. Yes. Here, basically, we have the same form. We are using the same
You are using
formula
the same form,
like linear regression.
you are using the same form,
Different cost.
but now you are using different coefficients and different
Yeah.
features. The features are a linear combination of the features that were given to you.
Yeah. Yeah.
So,
Yeah.
Sunil, any questions now?
No, no, I got this one. Could you minimize this screen so that I can see the table and the picture which you have drawn? Because it seems I am understanding back propagation now, but I want to see correlate these two, table versus the picture. Yeah.
Okay, you ask me your doubts so that I can clear it and it becomes more easy for you to understand. What is your doubt right now? I feel that you're not very confident right now. So just let me know what is your doubt first. Just a second. I'll decrease the time. Okay,
No, I don't have any doubt.
sure. Because I'm not feeling that
Yeah,
confident.
sure.
Uh, did you understand?
No, no. Basically just
Okay, I'll ask you one by one. Sunil, tell me what you are doing different in deep learning, what you're trying to do.
Basically, we have introduced some hidden layer
Excellent,
and
excellent.
number of layers, whatever. And basically, on the left hand side, whatever the input income we have put there, or not income, basically first row we have put there,
Uh-huh.
and based on that, finally we are calculating whether that is high or low.
Correct.
So for in this whole model, we are trying to find out for high, if we move from left to right, what will be our W or weightage,
Excellent, excellent.
which we are seeing beta and beta. And so because we are going from right to left to get this value, it seems due to this trigger, it's called backpropagation.
Amazing. Awesome, I would say. Claps for you. Excellent. So you have understood this properly. So
So
based
on one more, but basically I want to correlate this table versus the image which we have created.
slowly,
Why we have
we
put
will go to that.
high?
We will go to that. Wait,
Okay,
don't jump. Don't jump. Slowly understand each of the things slowly. First,
okay.
clear at this point of time. This is clear, right? Vasant, it is clear to you also?
Yes, Shubh.
Okay.
Good.
Now, imagine that I say I don't want just a single hidden layer. I want multiple hidden layers. So what will be your inference out of it? So for example, instead of only one hidden layer here, I have multiple. So let's say you have your you have 5 features. Now understand this. For example, you have 5 features. Okay. Now, using these 5 features, you have gone to a hidden layer. Each of these neurons, these are called neurons, is a combination of these 5 features. So you have reduced from 5, you have gone to 3. From 3, you have gone to 2. And then from 2, you have gone to your final output. Now, let me ask you a question. What if from instead of 5 features, I just drop to 3 features without this combination? What will be the difference?
But you will miss uh, some of the expectation.
Correct. Some of the information you miss. So, for example, in
Yeah.
machine learning, when we were doing our machine learning, and I was saying that instead of 5 features, you have 3 features. These were unimportant. So your hidden layer was kind of looking like this. We never said that it was a hidden layer at that point of time. And using this layer, you are trying to find out the output. So this is a very typical machine learning diagram. If you can see, these are the 5 features, and from these five
And
features, you are
work
extracting
and model.
3 important. and from 3 important you are trying to predict the final classes. Sunil, is this clear? So instead of using just these 5, I'm saying no, I don't want to ignore these. It can be the fact that this feature which I've left out, when it is combined with the first feature, it is important. Maybe this feature, when it is combined with this feature, this becomes also important, right? So that's why I am allowing all features to talk to each other. So this thing is allowing all the features to talk to each other. Similarly, this feature is allowing all the features to talk to each other, and it is now telling me that this thing, when in combination with these 5 features, this is really important. Similarly, this is taking into consideration all the 5 features, and combining these features, I am able to predict the classes. Sunil, any problem now? Wasn't any questions now?
What do you mean by really important? All these three will be important, am I right?
Yeah.
Oh, okay.
I mean, okay, you got confused by the diagram. These 3 are really important, like that.
No. Basically, all 5 we are combining and we are getting 3 basically.
Yeah.
So, how again that is given?
How you have not understood yet?
Yeah, up now it's clear.
Up till now it is clear. Now I've given you a hint of how we are doing, right? What we are doing is, okay, how will I explain that? Okay, let us see. Now you have 3 features. Okay, let us do it properly again. Suppose you have income, age, and OKX. So let's say your first feature is beta 1 income plus beta 2 age plus beta 3 OKX. Do you understand this equation?
Yes.
Sure.
Yeah. This is a linear equation we are getting from input and we are getting
A
one.
combination of, okay. Now let us try the second neuron. Let's say the equation is C1 income plus C2 age plus C3 OKX. Okay.
Yes.
Okay. So this feature, okay, now let us take out your calculators. Let's say B1 is 20, B2 is 30, B4 is 10, and C1 is 10, C2 is 60, C3 is 40. Okay. Your income is, let's say, 100, age is 25, work X is 2 years. Can you calculate me this neuron, the value of this neuron and value of this neuron? I will wait. Calculate me this.
Could you minimize the screen?
Okay.
Uh,
Yeah, it is coming.
so that we can see.
Yeah, it is coming. There's a lag, small amount.
Yeah, now coming. 20,000, 2,700 से 750 और 10 770 और यहाँ पे 20,000 2,000 2790 will be the first one.
First one is 27.
Where we are putting the guy. Yeah.
Okay.
The second one will be 1,000 2,580 2580.
How much?
2580.
Okay. I'm not.
Sorry, 25. Let's say 2580 it should be.
Okay, I'm not checking the values. So now,
Yeah, but whatever. Yeah, we are getting some. Yeah.
okay, now let's say your what where is the table? For example, your table initially 100, 25, 2, and the house he was buying was of 2000 units. So what was your linear regression equation? 2000 is equal to some b naught 100 plus b1 25 plus b2 2. This was your linear equation, right? Linear regression equation, right?
Yes.
Now instead of b naught
If
100,
yeah, if 2000 was the target.
yeah, correct. 2000 is the target. Now I am saying this is not anymore your equation. Your new equation is understand or not.
Okay. Yeah, it's clear.
Instead of 100 to 25 and 2, we are getting 2790 and 2580. Now your question should be how you got these, how you got the values of b1, b2, b3, I mean b1, b2, b4, and c1, c2, c3, right? That should be your question.
Yeah. Yes.
Now, when you told me about back propagation, you have yourself answered your question. So what we are doing is, first we have devised an algorithm that works from here. So for example, you're combining b1 into 100 plus b2 into age plus b3 into work x. Similarly, you are taking c1 into income plus c2 into age plus c3 into work x, and then you're combining this in d1. So for example, what is d1? D1 is again a linear combination of this neuron and this neuron, right? Your this output is a linear
Yes.
combination of this and this. So it will also have weights. So every connection has a weight, right? This connection was b1, this connection was b2, this connection was b3. Hello?
Yes, sir.
Yeah, you're understanding?
Yes.
Vasan, is it clear to you? I'm not getting see, if you don't ask me questions, I'll not be able to answer. Are you understanding what we are trying to do here?
Yeah, yes, Shubdeep.
Okay,
I
okay.
guess, yeah.
So you have weights with all the lines. Now, once you have 2790, or let's say this thing here, and the other one is here, okay, the c1 in, then again you're combining them with some weights. So these are the weights. Now when you're back propagating, you're trying to reduce this RMSE with the actual output and trying to find the values of a1, a2, and b1, b2, b3, b3, and c1, c2, c3. So every time you go forward, you're linking every line with the weight, and then when you're coming back, you're kind of reducing that RMSE. In linear regression, it was easy, right? You just had only one layer and you had to reduce these, right? But right now you have so many layers. You have a1, a2, you have to reduce. A1 is linked to b1, b2, b3. Again, a2 is linked to c1, c2, c3. So you're trying to reduce all these weights such that the final output is closest to your actual target. Like you were doing in linear regression, you are trying to reduce b1, b0, b1, b2 from that stochastic gradient. Here also you are trying to reduce d1 and d2. Okay, now how, if you need to reduce d1 and d2, then D1 is coming from where? D1 itself is coming from B1, B2, B3, and C1, C2, C3. So everything need to be reduced so that this function, I mean, D1 and D2 gets optimum so that you come closest to your target 2000. Not clear?
Hey, Subhadeep,
Yeah,
Subhadeep, if I understand, on this structured data we are doing this. So for the first row, we will get B1, B2, B3, D1, D2.
correct.
So the same value will be applied. The same value which I have got from the first row will be applied to predict for the second row
No, 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 no.
and the third row, and finally we'll try to get the RMSE.
No, 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 no. So we'll come to that. First, have you understood this part?
Yeah, for one row it's clear.
One row it's clear. So you have multiple rows. So did you have one point in linear regression? In linear regression also you had so many points, right? In linear regression, how was your line looking? You had so many points, right? So did you find B1, B2 for such only this point? No, right? You find out B1, B2
No,
all the points. Similarly, you are
yeah, for every.
For
you
all the
also
points.
here also you will find B1, B2, B3, C1, C2, C3, D1, D2 for all the points, and then you have one single optimal point.
That.
So only difference is between B0, B1, B2 and D1, D2. Instead of B0, B1, B2, you are having D1, D2, which is again a combination of these features. Okay, so there are layers. Okay, you're not reducing just one layer. It is not that you're reducing B0, finding the optimum B0, B1, B2. You're first finding the optimum D1, D2. D1 is again a function of B1, B2, B3, and C1, C2, C3. Similarly, D2 is again a function of B1, B2, B3, and C1, C2, C3, right? So you're finding this optima. So if you have to find this optima, you have to change this, right? So you have to change these, and finally, you will get the best D1 and D2 for all the points. Clear or not?
Yeah, it's clear.
Okay.
Yes, Shobit.
Wasn't clear for you?
Yes, yes, yeah.
Okay.
So, Subhadeep, one question. So, in this structured data, it's clear.
Okay.
But where we started initially from the car, means we don't know that is car or not. We have in image 84 cross 84, and we are not sure what is the output.
Correct. Correct.
If there is no output, how will we
No,
decide
no,
B1, B2, B3, or D1, D2?
no, no. So first thing is this is all supervised learning only, right? The output, you're mistaken. The output
Yeah.
is there. The features are not there. No one has told you these are the features of the car. You know which brand it is. You know it is this car, that car, but no one has told you and that this car has, let's say, the Honda design is like this. The tires are smaller than Mercedes, or uh, let's say the height is lower. No one has told you the features. Deep learning is all about features. Output is still there. Output, you have a database which already has the supervised learning part, right? The output is already there. What you don't have is the features.
No, no. No, what was our actual problem in that case? There was an image, and we have to predict whether this is car or not, or image was told that this is a car, and you have to let us know the brand. What was the actual problem in that?
Okay.
Cross 84.
Okay. Let's see what we are going to do in our uh, class today. So the code what we are running. So there's a data set called the MNIST data set. So you have handwritten digits, okay, 1 to 9, 0 to 9, and based on the handwritten digit, it has to predict the actual digit. So for example, if I write 2 like this, it should predict 2. If I write 4 like this, it should predict 4. So that is the problem. Okay, now there are let's say 70,000 images of these handwritten digits which are already supervised. I mean, there's an image for, let's say, 0, it already knows that it is 0. There's an image for 1, there's already knows that the output is 1. There are, let's say, 25 images of 2, it already knows this is 2. Okay, now when a new user, let's say, right, like I'm writing on my iPad, I'm writing it 3, iPad should automatically tell me that this is the digit 3. Okay, so this is called the MNIST dataset. So what you're trying to do is you already have the supervised database in your memory. So already, so see, why we introduce deep learning is like, you all in machine learning, what you had features and you had an output, right? This is was your machine learning problem. In deep learning, output is there, but you don't have the features. No one has told you this, these are the features, this is the income, this is the age, this is the height. No one has told you. It is, you are given a certain number of pixels. There are 784 pixels for image, and based on these 784 pixels you have to tell whether this is a number 1, number 2, or number 9 or so. But you already have,
So in our example of the
yeah,
so in example of the car, image was given. What was the output given to us in that case?
so output already is given, the brand is already given. Now for example, a new image comes, you have to predict the brand of that car. Suppose you have collected from Google, you have collected 1,000 images of cars with their brands. Okay, so for example, you have gone Honda and you have collected 10 images. You have searched Mercedes, you have found out 13 images. Like this, you have collected a database of 100 images. You have trained your model, and then someone comes and gives you an image of, let's say, a car. Then you have to predict whether this car is a Honda or a Mercedes, like that.
Okay. So sorry, frankly speaking, I couldn't understand this. So take an example that we have got an image. At
Yeah.
the same time, Google has 100 of images
Okay.
with the given brand.
Okay.
So coming on the Google side, Google has features for those stored images or not.
See, Google will not have features. That's what I'm trying to say. Deep learning doesn't have features. It doesn't have features. It has the image, except,
Yeah.
just keep that same analogy. Don't get confused too much. In machine learning, you had features and then were predicting the output, right?
Correct.
How you were predicting the output? Based on your past data, you have learned that these features are combination like this, and you're trying to predict the output. In deep learning, your features are not there. You just have an image, let's say. Can image is image a feature? It is not a feature, right? It's just a photo. Now you have past historical, same thing, past historical images with
And output.
an output is there, right? Now someone comes, gives you a new image, tells you to tell me which brand it is.
Okay, so we are going to check the features.
Understand now, or is still confusion is there?
No, it's clear now.
So just, okay, let me ask you, what we are trying to do in our image classification problem, tell me.
No, sorry. Basically, in image classification, we have to decide which brand of this car is.
Okay.
No, we are dividing the pixels.
No, that is okay.
Then
I mean, what is the objective? So for example, in image classification of a car, what is given to you already? What is your trained data? I mean, what is your data that you have to train your model on? What is the data?
Image and output. Earlier, it is stored in database.
Correct. Image and output. Image and output. There's a car of Honda, and their image is present, and the output is present as Honda. There's an image for Mercedes. The output is present as Mercedes. Like this, you have, let's say, 1,000 images. Now, what is your objective? Someone comes up with
Object
a image of a car and tells you, and you have to tell
to
him
predict the brand.
exactly. Okay. Vasant, clear on this?
Yes, Shubdeep.
Okay. And how are you predicting?
Yes, that thing I'm telling you means how we are predicting. In this case,
Based on the
for
past,
the new
it will be
for the
getting
new
like,
problem.
it will be
Yeah, please.
getting the width and everything. Then it will compare with the past data.
Correct. So your past data is there. So your past data, all the images will, let's say there were 1,000 images in your database. Okay. So each image will have 784 pixels. Based on those pixels, considering those pixels as features, the model will understand if these are the pixels present in an image, this car is a Honda. If these are the pixels present in a image, this car is a Mercedes. So based on those pixels, the model will understand whether this car is a Honda or a Mercedes. Okay. Now, when you give the model a new image, based on the pixel, it will try to predict whether this car was a Honda or a Mercedes. This car is a Honda or a Mercedes. Okay. Just in your mind, replace that. Instead of features, we have pixels now. Sunil, your question now. Tell me, what is confusing you?
Yeah, it's clear now.
I don't think
It's
you're
already we have
very confident.
no. We already have images in database so we have the pixels as a feature in database,
Correct.
and here we have images with pixels, and pixels in another way features, and based on these features, we have to match which brand it will be.
Correct. Amazing. Okay, so now we have understood what was the problem and how we were solving it. Now let's get back to our input layer and hidden layer. Okay, now let's see. So for example, the handwritten digits, like I was telling you, right? So for example, these are the digits, like 3, 4, 2, so many digits are present. You have to predict your output should be, what is the digit here, 0 to 10, which is the digit. Okay. So for example, you're training on an image. You have selected an image. Just a second, there's a lag. Okay, now you're training. So first,
Subhadeep, just 1 second. And sorry for asking this foolish question. So, coming on that again, image, we are assuming that Google has image with pixels, and that pixels we are assuming as features.
correct.
If once we have assumed this is already a machine learning we have already learned. Means, where output is given, and we have the predictors.
How you are saying?
No. Okay. Let me rephrase my assessment again. So Google has 100 images. For every image, there is pixels, and that pixels we are saying that is a feature or predictor, and we have output for that in the database.
So,
am I right?
See, when we are doing deep learning, what we are doing is we are allowing the features to talk to themselves. Like I just give you the figure, right? If there are 5 features and they don't talk to each other, the pixels need to talk to each other, right? Because this is of relative sense. Imagine, let's say a Honda is there, and let's say, how will I say? Okay, now let's say the car is a Honda, and the pixels need to talk to each other. My pixel should understand the nearing pixels. According to that, I will be able to tell the height of the car. If Just understand this, These are all the things are relative in a pixel. If I take just absolute pixels, it will not make any sense. If I just do a machine learning problem on this, what you have different pixels independent to each other, and you're trying to predict the output. That will not give me accuracy. You need to tell the algorithm that all the pixels need to talk to each other, right? The top corner of top, do you, first of all, do you understand what are pixels in an image?
Yes, yeah, RGB or CMYK, this is
Correct, correct.
which we store. That's I think I understand.
So the top corner has to understand, let's say, the if the image has a cloud on top of it, and then the car is there, so the pixel has to understand the relative sense of space, right? So the top is a cloud, the bottom is a car, then the car's shape has to be understood. The shape is relative. So if the line is like, if the roof is flowing like this, so everything has to be relatively understand. All the pixels need to talk to each other. If the pixels do not talk to each other, then my output will not be good. You are right, I can do a machine learning problem if I have a 784 pixels and I use those pixels as a features. You are correct, absolutely correct, I can do a machine learning problem. But in machine learning, your features are not talking to each other, if you remember, right? You're taking these features or the important features you're trying to extract, but your features are not talking to each other. You need your image. That's why deep learning allows the pixels to talk to each other. The combinations, when you're combining 784 pixels and combining them like in linear combinations, you're allowing all the pixels to talk to each other. That's where the relative sense of pixels and the space will come up. Does it clear your doubt?
I can't say.
Okay. Okay, then ask the question. What is the problem?
So basically, one height you introduced another feature that by talking which means pixels, they are calculating the height,
Yeah,
excluding the clouds and everything.
correct.
It means we are extracting one new feature height. It means in the previous database which Google has, it will have feature height also. Then only there is a need of calculating the height.
No, no, no.
Okay. I mean to say, which feature for a particular car we are trying to extract.
Many features,
If they are
edges,
not many
lines,
features.
colors, everything you're trying to extract. That's how you will build the car, right? How will the car be built?
Okay.
It will have edges, it will
Okay.
have lines.
Okay.
Yeah.
Go for 5-6 features as like width is there, then
No, you
height.
cannot go with 5, 6.
Yeah.
That's the problem, right? No one has told you that there are 5, 6 features. Did Google did I mean, how will I explain? Did someone tell you that the Honda car height is like this, width is like this? Did anyone tell you? No, right? You don't have the
No.
that is the problem. You just have pixels, lot of numbers, 784 numbers. How to make sense of that?
Yeah.
Machine learning will not know, right? You just have, so for example, if you have age, income, work x, okay, so you have a combination of these features and you're trying to predict the output. But if you have 784 pixels, each pixel needs to talk to each other to understand the shape of the line or shape of the car. Let me draw you an image, okay? For example, this is your image, okay? This is a box. Let's say 28 cross 28 pixels are there, okay? Now the car is something like, it looks like this, okay?
Assuming this is your car, rectangle is your car.
Yeah. Okay. Now this pixel needs to talk to this pixel that we are forming a curve. This pixel needs to talk to this pixel that we are forming a curve. This pixel needs to talk to this pixel that I am above you, such, I mean, let's say I am 4 centimeters above you. I mean, not literally, but what I'm trying to say is each pixel needs to talk to the other pixel that this is the edge we are talking about. This is the tire which we are talking about. Did anyone go to you and tell you that your Honda car has tires of 16-inch? Did anyone tell you that? No, right? You have pixels. The pixel
No.
will itself talk to each other and understand that this is a 16-inch wheel, or it is a 3 centimeter or three what do you call 4 5 meter length of car. So each pixel needs to, this pixel here needs to talk to this pixel, and it says that the car is this much of length. You're understanding the point? Our machine learning,
Yes.
our machine learning will talk, if let's say these 784 28 cross 28 pixels were fed into machine learning, what will happen? This is fed, this is fed, this is fed, this is fed, and you have a model, and it will give you an output. But did this pixel talk to this pixel? No, right? It came to the model, this came to the model independently. It never understood that these are clouds and this is the road. It didn't understand. How will it understand? It will understand when it talks to each other, when it, everything, this pixel takes inputs from each other, from all the pixels. It will understand, okay, I am at the top, I am the cloud. When this pixel talks to the other pixels, it will say, okay, I am at the ground. So each pixel has to talk to other pixels, right? It cannot be fed
Correct.
independently to your model. Does this help you to understand a little bit?
Yeah. Yes. Yeah.
Okay. Okay. So see, deep learning is difficult. I have to say that. I mean, it's little difficult. It has to, a lot of maths is involved. But I'm trying to explain you the most intuitive way that can be possible. So, if is this clear till now? Can you, if it is okay, Vasant, what about you? Do you understand? Did you understand
Yeah,
my
yes,
questions?
yes,
Okay. Okay. Perfect.
yes.
So Sunil, I think this, it was a good question that you
Yeah.
asked.
Now it's, yeah,
Yeah, it
at
was a,
least a little bit clear. Yeah.
yeah, good question that you asked, why we are taking 784 things. Okay, anyways. Okay, now let us see this. For example, these are the numbers that are present, and based on these images, you are trying to predict whether this number is a 0 or a 1 or a 2 up till 10. Okay. Now, for example, take an example of image 4. Okay, so this image has to be classified under what?
4.
4, exactly. So for example, your output, let's see, just see your output here. So this is your actual output. Okay, this is the actual output. For 0 it is 0, 1 it is 0, 2 it is 0, 3 is 0, 4 is 1, the actual, 5 is 0, 6 is 0, 7 is 0, 8 is 0, 9 is 0. Okay, this is your actual output. Now what should be your predicted output?
Selected should also be 4.
4.
It should be 4. I mean,
Yeah.
this cell should be the highest amongst. So these are probabilities. So ideally it should be 1, but it may not be 1 every time. So this should be the highest, right? So for example, you take the pixels of 4, and all the weights and the calculations end up with this matrix. Okay. Now you have seen that my current vector is not very good, right? The error is huge. What should be 0 is 0.1. What should be 0 should is 0.3. What should be 1 is 0.1. What should be 0 is 0.1. What should be 0 it's zero point 0.4. Okay, so you have understood that this is very far away from y. So you go back, you do a back propagation, you recalculate these weights again, so all these connections are again revised. Okay, and then you again come back, then you again form y hat, and then you see what is the error, then again you go back, revise these weights like this. So what you do, go a forward pass, calculate the cost. The cost is the error function, so the error is huge, right? 0, what should be, ideally these all should be 0, this should be 1, and again these should be 0, right? But it is not. So what you calculate the error, you again go back, revise these connections, again come back, again do a like this, you continuously do this. Okay, and finally you get the updated weights which give you the final this thing. Are you understanding this?
Yeah.
And no, I don't think you have understood. Ask me the question. What did you? What?
It will be on Y prediction. So
Sorry.
what is 0.1, 0.3 and
Okay. Let me.
not actual Y prediction?
Okay, you're saying what is 0 point? Okay, you remember binary classification problem in our iris? Do you remember iris when we used logistic regression, or when we're doing a classification problem? The classes,
Yes, yeah.
the output classes have probabilities, right? So
Yes, probability, yes.
did you see ever 1 0?
Whatever is the
It was sometimes, let's say, zero point 0.7, zero point 0.3, or 0.8,
yes,
0.8, 0.2. So your outputs were probabilities. Here also your
yes.
outputs are probabilities. You want the actual
Okay.
probability, or you want this probability to be the highest, so that that can be denoted as 4. So these all are probabilities. What is the probability
Okay.
of being 0? It is 0. What is the probability of being 1? It is
Yeah.
0.1. What is the probability of being 2? It is 0.
Okay.
Okay,
Got it.
so these are the
Yeah.
probabilities of these classes. So just imagine this, forget this thing, just imagine this to be a machine learning problem. What happens? You give features, and then you get the output, right? So if the output has 10 classes, each class will have a probability associated with it, right?
Yes. Yeah.
Okay, so Neil, now your
Okay.
question.
Basically, that's a probability that's clear, and that is the 10 multi-classification problem where we have
Exactly.
10 outputs.
Correct.
So that's not an issue. Only issue, still I'm trying to figure it out, feature extraction, because only once we will have feature, then only we can predict that.
Okay,
So what feature we have extracted from this one?
that's what, see.
Y1, Y2, these are,
So Neil, see,
sorry, space.
that's your feature extraction the algorithm is doing. So what do you think this hidden layer is? This is extracting.
These are the features. Yeah, these are the features.
Exactly, these are the features, right? So using these features, it is predicting this.
Correct. So A11, A21. So what do I think? I means A21, A22, A23. These are the final features which is getting used in our previous data.
Yeah, so so for example, this is your hidden layer 2, and this is your final output.
Yeah.
So the features in the hidden layer 2 are being used to calculate your final output.
Okay, got it.
Okay, now let's see. So for example,
Okay, I mean to say, Subodhi, break this question in two parts. One part that is the prediction.
okay,
First part that is to get extracting the feature.
okay.
Can we assume like this one?
So till the hidden layers, you're extracting features. After the
Yeah.
hidden layer, you're calculating output.
Okay. Okay. So my question is that the last hidden layer, means the rightmost hidden layer, that is getting used to get the output?
Correct, correct.
Oh,
Now, so you can have
okay, got it.
100 hidden layers, and then you have an output. You can have two hidden layers, and you can have an output. But the last hidden layer will be the final features that are going into the model.
Okay, got it.
Got it?
Yeah.
Oh,
It means
yeah.
as like our rightmost hidden layer, those will be the features which we are going to use. It means similar type of features are already in the database. So, and we are going to reduce one by one features. I mean, hidden layers, number of neurons in the hidden layers, we are decreasing.
No. The first part of the sentence was correct. Till you have understood that hidden layer is the
Okay.
final input to the feature, input to the model. Again, I'm again saying the database contains these pixels. The database does not contain these. This is the algorithm is deriving from x1, x2, x3, x4. No one has
Okay.
extracted a1, a2 for you. you have extracted from your model. The database contains x1 to x whatever 784. These are the pixels, original pixels. These are the original features or the pixels. From these pixels, you are allowing them to talk to each other. You are allowing them to talk to each other, and then you're finally predicting the output.
Okay. So if we discuss in this example,
Uh,
everything is working fine. We are getting some probability in multi-class problem.
okay.
So have we applied back propagation in this or not?
Yeah, that's what I said. No,
I
your
don't think.
initially weight
No. Yeah, definitely not.
initially your weights were given. What I've written here, forward pass, there's a cost function, right? But this cost, I mean, this output is not correct, right? Your output should be 1 here, but it is the output has a lot of error in it. You go back, you retrain your
Okay.
W, not W1, W2. Again, you come back. Again, you find the Y hat. Then again, you find the error between Y hat and Y. Then again, you
Yeah, got.
go back, retrain your W1. Same thing as linear regression. Just kind of try to put that analogy. Same as linear regression. Linear regression, what you were doing, you were trying to predict b naught plus b1 x1 plus b2 x2. You are trying to do a stochastic gradient. So in order to achieve this as a minimum, right? So many a times you are going back, you are minimizing the error and again deriving b1 b2. Same way, again you have the cost, you are going back to the backward pass. So this is the cost function which has to be minimized, right? So in order to minimize, you're going to
Yes.
backward, you are retraining these things, you are re-deriving the connections, you are again re-deriving all these connections. Okay, and then again you're giving me an output.
Correct.
This output has an error. This error is needs to be minimized.
Then go back again and do.
Go back again you're deriving these changing these connections, and then again you're coming back to the output. Okay.
So yeah, there is one term basically. Convolution. I have also heard about back propagation. So again, that convolution is used for only feature extraction or some other thing.
Yeah, so convolution is used for feature extraction. We will come to that convolution, but
Okay.
don't confuse yourself first. Are you clear with this?
Yes, 100%.
100% clear, right? No confusion at all.
No.
Awesome. Okay. Now, the next concept is called activation function. Okay. Um, till now, what I've told you, you were linearly combining these, right? Right? You were linearly combining. Means you were multiplying with W not X, sorry, W1 X1 plus W2 X2. These are the linear combinations, right?
Yeah, we have assumed that yeah, that can be other combination also.
Okay. So in order to make these linear combinations non-linear, you have something called an activation function. Okay. So we'll not go into depth with an activation function because it's a little too mathematical. But just remember this. Now understand this. First, first you have your image. You have 784 pixels. Why we are using deep learning and not machine learning? Because you want to make the pixels talk to each other, right? You want the first pixel to talk with the last pixel, you want the first pixel to talk to the second pixel. So that's why you are kind of combining all this and finding the neurons. Okay, now initially you were combining this in a linear way. Now you say, why I don't allow them to talk in a non-linear way also? Why let them have a non-linear conversation also, right? So it's always not, what we have learned in machine learning is that linear does not solve your problem every time. You have to go towards non-linearity at some point of time. This also, you have to allow the first pixel to talk to the other 783 pixels in a non-linear way. Okay, so that will be done by the use of activation function. Okay.
Yes.
Okay. Now let me ask you a question. Uh, I will ask the same question you asked. I want to hear your answer. Uh, what if I used machine learning in on my original image, 784 pixels? What will I lose there, or what will I not gain there?
Could you repeat your question once again?
If I use normal traditional machine learning problem or algorithm on the image of 784 pixels, what will I lose or what will I not gain from the learning? Why we cannot use machine learning on 784 pixels? What is the
No,
difference?
basically that was the straight question, because we need to calculate how pixels are related to each other.
Exactly. Okay, so that means you have understood this concept. So you want the pixels to talk to each other. You want the features to talk to each other and get and derive features which are combinations of these original features. Okay.
Yeah.
Okay. Vasant, are you clear on this?
Yep. Yes. Yes. Shobhit.
Okay. So
So there will be different frameworks to apply, like TensorFlow, like that.
So TensorFlow framework, if you need to apply, you have to install that framework. So for example, right now I will show you how to apply your deep learning on a Neon framework. Okay. So Neon is an Intel
Okay.
framework, but TensorFlow you have to install. Now, if you want to go for the
Okay.
deep learning course, we will see how we can apply deep learning on the structured data, how it improves the accuracy, how your features are generated, new features are generated from the existing data. So that is different from today's session. That will be a separate course. But right now we are trying to understand the
Okay.
basics. So this loss function, I'll not go into depth. So I'm planning to start with convolutional neural networks a little bit, but I think you still need to have a better understanding of the basics. Okay, let me just introduce convolution networks. So, um, right now I said that your first pixel needs to talk to the 784th pixel. So how many combinations you will have? First pixel will talk to 783 pixels. Second pixel also will learn to talk to 783 pixels. So if you have 784 pixels, each pixel talking to other
Interesting.
783, how many parameters will be there? Huge, right? 784 into 783.
Interesting. You are correct.
Yes. Yeah.
Right? So many parameters. So, and for example, if you have 1 lakh such images, then your model will crash. So many parameters, so many images, it will get confused. So why convolution? What is the concept of convolution? So initially what we were doing, just a second, my battery is low, just a second. Okay, just let me allow me a 2 minutes break. Let's get back after 2 minutes, huh? And just drink some water.
Okay.
Hello. Hello.
Frodo.
Yes, Shabdip.
Yeah, you guys can
Yeah.
hear me?
Yeah. Hi.
Okay.
Yes.
Okay. So let's discuss with for convolution. Okay. Now first understand what it was. Okay. So you understand the complexity, right? If each pixel talks to other 783 pixels, then the number of parameters we are looking at is humongous. What convolution says is let pixels talk, but let the surrounding pixels talk. Okay, don't allow the first pixel to talk to the last pixel. I don't want the cloud pixel to talk to the road pixel, because the road pixels itself will understand from the car that the road is below the car. Why should I take into consideration the pixels of the cloud? Okay, so why I need the pixel of the road to talk to the pixel of the cloud? I already know that I am a road because the car is above me. Similarly, the clouds will tell why I need to talk to the road. I know that the road is below the car. So if I talk to the pixels of the car, I itself know my position, right? So convolution uh, uh, is a method where each pixel is not talking to all the pixels. For example, let's say this pixel is talking to this pixel, this pixel. This pixel is talking to this pixel and this pixel. Earlier, what used to happen? Earlier, this pixel used to talk to this, everything, right? But now, this pixel is only talking to selected pixels, which is closer to closer to that. Okay, so I don't want this pixel to talk to the first pixel, right? Because I already know my position with respect to the car. Why should I take my position with respect to the cloud? So convolution is the
Then
same.
why? Sorry. Then sorry. Sorry. In one D convolution, why third is not talking with two?
No, no, it's just a representation. It's not
Okay.
yeah, it's just a representation. Okay,
Okay.
so
Right.
yeah, so convolution will allow you to reduce the complexity of your algorithm and disconnect the pixels which are far off from the current pixel we are talking into consideration. Okay, so that's what convolution does. So not go into depth of convolution because it's a completely different topic. What we will do now is we'll go into the code of deep learning. Okay, so I will connect my laptop.
Yes, Suri. It means in convolution there can be different cases, whether we have to escape one pixel or many pixel, or I mean there should be some strategy.
Yeah, yeah. So you're right. So there's something called filters. Filters will take pixels which are together in a space. Okay. So let's say first top 5 7 pixels are together taken into a filter. So those pixels will talk to each other. They will not talk to the next filter, which is 7 pixels away from them. So like this, the convolution is done. So if you see the meaning of
Okay.
convolution in Google, can you see my laptop screen?
Yes.
Okay. Um, Okay, it's not giving me the exact definition I wanted to see. Anyways, that's okay. Okay, so now let's see the code for the handwritten digits. Okay, so this is the Neon framework. Okay, so Neon framework is basically like the TensorFlow that you have. So this should be pre-installed in your machine. Batch size is 32. What is batch size? Batch size is basically, for example, if you have 100 rows, you don't want to take all 100 rows together. You're taking 32 rows at one time. Okay, so you're taking limited batches. You're not taking the whole data together. Okay, this is to reduce the complexity. Okay, now you kind of import the data, train set and the validation set. Okay, then initialize weights. So what we have seen here is those weights, that W, initially there has to be some value, right? You cannot keep it as 0. There has to be some value. Based on that, you will do your forward pass, then you will calculate the cost, and then you will do a back propagation to reduce, to optimize those weights. Remember?
Yes.
Yes. Yeah.
Correct? So
Yes.
initially those weights should have some value, any random value, but it should have some value so that you can get the forward pass done and you can calculate the output. Then you calculate the cost and then you come back again and then you go like this. So this circle comes. So weight should be initialized first. So how you initialize a weight? You just take random sample from a Gaussian distribution. Gaussian distribution is nothing called but a different name for a normal distribution. Okay, so you take initial weights as with mean 0 and standard deviation as 0.01. Simple way of initialization. Now, what you do is you create two layers. Okay, with these weights, activation is the linear function that we saw in the image, but you don't have to be so I mean, you don't have to understand right now, just you know, keep that in mind. So that is not to be dealt too seriously right now. And then you connect another layer. So these are the different layers. This is the first is the hidden layer 1, second is the hidden layer 2, and then there's an activation function called softmax. You initialize these two hidden layers. Okay, now hidden layers, you have to tell. Hidden layers, the algorithm will not take into consideration. You have to tell how many hidden layers you want. More the hidden layers, the thumb rule is, more the hidden layers, more is the accuracy of the model.
Yeah.
Okay.
Right. That's
Now you import the model. You save the model in MLP. Okay. You declare the cost function. Cost function is the cross entropy function for classification problem. Multi classification, like we are doing 10-way classification, you use the cross entropy. Remember Gini index in decision tree, it's almost the same thing. Okay, so you're doing the cross entropy function as a what do you call the cost function. Then you are doing the optimizer. This is the gradient descent optimizer with the momentum. Don't need to understand that what is momentum, but just understand gradient descent is the optimizer. Then you call the function, and here you see. So epoch 1, epoch 0 is the first trial. So you train 18775 batches because each batch size was 32 based on the number of total total number of data points. So each batch will contain 32. So 1875 into 32 will be the total number of data points. This is the cost you're getting, and slowly you reduce the cost. Okay. So your optimum cost is actually reached here only in the 8th epoch. Okay. Now this is where you store the results. You find the misclassification error. So error is 89.3% because it's a very shallow shallow network. Okay, so that's why it has you just have two hidden layers, and then you try to find out so this is where you input a new image and try to predict. So but our prediction is not very good. We have input our image as 4, but the digit it is saying it is 6. Okay, so it is not very good because we have not optimized it. but that is how your flow should be. Okay, did you understand this flow?
Yeah, flow is
Yes.
good, but code-wise it's difficult.
Code wise it's difficult, yeah, it is. You don't need to understand the code right now, but
Hmm.
like what we have learned, like first we have you have to initialize the weight. Why you need to initialize the weight? Answer, come on. Why you need to initialize the weights? We just learned, right? Why? I just told you why you need to initialize the weight.
Yeah, because it should not be zero. Whatever we have to give any point to anything other than zero, so
Excellent.
that it can fix itself.
Excellent. So you have to keep something other than zero. So you randomly assign. Very good. Then what will happen? You initialize the weight, you get your first output. Okay. Now you have to do a back propagation. So you, for that back propagation, what you have to do? You have to initialize your optimizer. You have given stochastic gradient as an optimizer. Before that, you need to declare your cost function. For a multi-classification problem, you give a entropy, like the Gini index we kept, entropy or Gini index, anything you can keep for your error. Then you do a back propagation, and like this, you train your model, and it will give you a result. Okay. So this is the overview of very brief overview of deep learning. So there are this, it's very powerful. It's just a very simple, imagine if you if you do a simple machine learning problem on this. So for example, if this is 28 cross 28 784 features and you do a machine learning, you will get an error of almost 99%. You just have an accuracy of 1%. It is very difficult for machine learning things, because see, it has to see the relative sense. This pixel knows that the surrounding pixels to its left and right is black. This pixel knows that the top pixel is white, the surroundings are black. So this is how the line will be learned, right? So all the pixels will know that my surroundings are black, my top and bottom are white. Okay, like this, it will learn the relative sense of the number 4, and accordingly, it will predict the number. Okay.
So, Shubhadeep, could you go on the line where we are using either back propagation or convolution?
Convolution we have not used here. We are doing a back propagation.
Not here.
Yeah, back propagation is this one: callbacks, import callbacks,
Okay.
and then you use the MLP.fit. So it's like you did your random forest dot fit, RF dot fit. Similarly, you do your MLP.fit. So this is your training, the optimizer, the number of epochs you need to keep, the cost, and the back propagation. Okay.
Yes.
Okay. So we'll not go further today. So now what I'll do is, address any questions you have related to all the lectures we have learned. Anything you want to ask, anything you want to know in general, the forum is open for questions.
So only one question related to sorry, Basant.
Sorry, related to what?
I thought Basant was asking some question.
Okay, Vasant, you have question?
So
No.
Okay.
so okay. So Shubhadeep, related to machine learning, only one question. Then I'll go on deep learning.
Okay.
So on machine learning, there is one instance based, another one was model based.
Okay.
So model based I understood because we have given different models and we have used that. But instance based, that was not very clear.
I didn't get instant based. I mean, what you're trying to ask? What is instance based? You're talking.
I was going through one of the book, machine learning through TensorFlow. Exact name is hands-on machine learning with scikit-learn and TensorFlow.
Okay.
So it was saying that there was some object-based and model-based, basically.
Okay.
Prediction.
Okay.
So in model based, just we pass the different models and we get the value,
Uh-huh.
which models we have already gone through. But instance based means it was written something I could not understand.
Okay. So I am not understanding what is object-based or instance-based. Maybe if you can read that line, that will be helpful because I'm not.
Okay, okay, no problem. I'll figure it out. Otherwise, I'll write you on the WhatsApp.
Yeah, yeah. You asked me the question
So
on WhatsApp because it's
very
one
sure.
generic term that
Okay,
if you can let me know the line, I can clarify your doubt there.
okay. Time being, there is one more. What is this reinforced? There is one other. I'd like
Reinforce,
to provide. I
yeah,
mean,
reinforcement learning.
reinforced, where it was
Reinforcement.
saying that system model will be punished or it will be rewarded. Based on that, it will learn.
Correct.
And there was a go game in which it
Yeah, yeah.
defeated the champion.
I understood. So reinforcement learning is a very different field. For example, chess. Like chess is something. For example, it's not just about predicting your next output. Okay, it is kind of predicting your output and also thinking the probable outcomes of the next turn of your opponent, and then also predicting the output, and then again thinking the more probable outcomes of your opposition. So for example, chess is not an independent thing, right? Like if you do if you conduct a turn right now, this turn may have repercussions after 10 turns, right? So what reinforcement learning does is it kind of evaluates all the scenarios based on which, for example, if I move the queen from left to right, what are the repercussions and what are the uh, probable moves that your opposition can do, and see 10 steps in future and understand whether this move of the queen from left to right was good or bad. Okay, so it is rewarding if it was if the turn is good, then it is rewarding that turn. It means your let's say you're adding your score function or the cost function is being reduced, and if it is making a bad turn, then your cost function is being punished. It means the cost function is increasing. Now you need to find the most optimum parameters to reduce the cost function overall. Okay, not just now, but even 10 steps in future. So all the strategy games like Go is also a strategy game, right? So your current move will be affecting, let's say, 20 moves down the line. So you kind of take all the possible scenarios and try to reward your algorithm to reach that scenario by using the cost function. So if that scenario is favorable to you, you reward that. You decrease your cost function, and if your that move is like it is disadvantageous to you, then you punish your move. That's how your reinforcement learning is done. So another naive example is teaching a robot to move, right? So, for example, if a robot is moving on a line, for example, you have asked the robot to follow a path. Okay. So, if the robot goes into another path and crashes, okay, so that is a punishment. Okay. So, you come make that robot stay there and then again bring it back to your normal track. Again, then it moves along the path and then sometime it goes away from the path and crashes. Okay. So, that is again a punishment. You let the robot crash and know that if you go away from this path, that is not a favorable outcome to you. So you bring that robot back to the path and again let him go on his new path. So that is what reinforcement learning does.
Okay, but as like machine learning or this one NLP, it's not so popular. Or
Because
what this?
no one actually knows what is reinforcement. People are still researching on how to get reinforcement learning into actual algorithms, how it can be used in businesses. Still is a research. So NLP, deep learning, reinforcement learning, people are improving day by day. It's not what research has not been completed yet on this. So reinforcement learning, people don't still have not found out good use cases for that. That's why it's not very popular.
Okay. And in NLP, means what are the things which we need, means we have not covered?
The NLP we have
Means,
not covered at all.
definitely.
We have which,
No. Basically, what we have learned here, that feature extraction, that is the first task for which there can be different strategy,
correct.
as like back propagation, convolution, and then once we have applied the machine learning. Either internally it will be applied, or we can apply externally, because you have got the features.
Okay.
So it means we need to, once we will start deep learning, we will learn more and more algorithms to extract the feature.
No.
Or okay.
In deep learning, so for example, you will learn more. First of all, we have just gone through simple neural networks. Okay, so like you have understood about basic images. So in images, convolution. So how to implement convolution neural networks, how to change the hidden layers, how to improve the accuracy of the model. Okay, that is one part. Then it will move on to time series forecasting. How long there's something called long short term memory. How you can use LSTMs to predict your sales. How your neural networks can retain the memory. So whatever like we said that example, your Apple example, right? That the apple was dropped in the kitchen, and where to find that apple. So it has to be stored in the memory. So how the neural networks can store things in the memory. So a lot of use cases are there, right? So then there is something called auto encoders and decoders. So if there's a high dimensional data, how to reduce into a lower dimension, and then again get back to a bigger dimension. Many things are there. Deep learning is huge. I mean, and the power of deep learning is amazing. I mean, you will be surprised to see the outcomes in deep learning. NLP when combined with deep learning is, so for example, we found out the word embedding using TF-IDF. There are numerous other word embeddings which understand the context. Those okay, let me show you one example. If you have if you are seeing my laptop. So for example, what we learned what we learned yesterday, what different types of word embeddings: frequency based, count vectors, TF-IDF. We stopped here. Okay, then there are word embeddings that are used, like skip gram, prediction based embedding. So like, let me show you. Frequency based and count vector we have seen. TF-IDF we have seen. Co-occurrence we have not seen. That's okay. Uh, See, the continuous bag of words model. This is using neural networks, input layer, hidden layer, output layer, to find the word embeddings, right? Then there's something called skip gram model. This is also using neural networks, deep learning, to find out the word embeddings. Okay, so there are many things which, I mean, you see how it is powerful. It can, if I use a TF-IDF or count vector, my similarity between a woman and a man will be 0. But if you use a word embedding, it understand the context. It understand that man, woman are different types of the gender. They come from the same human being. Okay, then you see how it can catch the similarity: woman king and negative man. Okay, so it says that it means it is queen. Okay, so I want to have the alternate word of woman and king, but it should not be a man. Okay, so it tells you that queen is the most probable word. So huge use cases. It's just an example what we are seeing. A lot of things go into analysis of news articles and sentiment analysis to predict your stock prices. So you can use your sentiment analysis and then use a LSTM to predict the stock prices. So I think
LS
Predict the stock prices. LSTM, long short-term memory.
Oh, okay.
Okay.
So, assuming sure if someone is asking you whether are you familiar with deep learning or not.
Okay.
So, what we have covered today means feature extraction and applying to three methods. So, is this enough, or are there some other terms which we need to learn?
No, this cannot be enough. Right?
Question is whether okay. So again, repeat my question. Someone is asking whether you are familiar with deep learning or not. That is the question.
Familiar? Yes. No. No.
Okay.
Knowing. Let's see. Let's say that you have learned the linear regression in machine learning. That's all. That's all.
Yeah.
So do you know random forest? No, you don't know random forest. Do you know decision trees? No, you don't know decision trees. You've just learned the linear regression part of deep learning.
Okay.
Okay.
Okay, that's fine. I think so. I've got a lot of things from you, and definitely you are very, very good. No need
No,
to say.
no problem. I think I mean I really enjoyed teaching you guys. You had a lot of good questions, and the best part is that like I really feel satisfied when you guys are saying that okay, I learned something, and I because I'm it doesn't feel good if you don't understand and I cross that topic. So I feel very bad if people have not understand that topic and I move on towards the topic. So that's why I keep on asking whether you understood or not. It may take us 15-20 minutes more, but I need to make sure that you guys understand, because that's what that's only when you will get a good night's sleep and I also get a good night's sleep, right? So I think my objective was to make you guys understand whatever we are learning. But again, machine learning has to be practiced. It is not that you have learned and you can rejoice the fact that you know everything. No, it's not that. You have to constantly practice. You have to apply, more specifically come up with any doubts. I will always be open to your doubts, whether we are in the course or not. Any doubts you have, you can anytime save my number. You can anytime ping me that I am facing this problem. How can I solve? Since I have done a lot of modeling right now, so I know which kind of problems can be solved with what models. So you can always ask me what is your use case, how you can apply analytics. You can always call me and ask that I have this data. Can you give me ideas on how we can apply analytics? Okay, so I'm always open to that conversation.
So, Sudeep, one more question.
Yeah.
So, still the first question we started: data scientist versus machine learner or programmer. So, what they actually do means they get the data, they remove unnecessary parts, they make it structured, remove the redundant data, outliers, these type of things, and then they hand over to us or something else.
So data scientist and machine learning engineer or a machine learning scientist will be almost the same. A data engineer, or let's say a database engineer will do some things like that. Get you the data, make sure the data is a proper condition, check the sanity of the data, and then give it to the data scientist. Okay, so to apply his analytics. So machine
Yeah, because we
learning.
can also do that too.
You can also do that, but normally you need to learn databases like SQL queries. You need to know the SQL
Okay.
queries to extract data from databases, and I mean that is there. But yeah, I mean you guys are now familiar with data cleaning and all.
Yeah, definitely. Thanks a lot, Suri. At least means everyone has learned a lot, and particularly me,
Okay,
200% I have learned from you.
thank
Because
you.
yesterday I was going through one of the books. Just
Yeah,
I was scanning you whether I know anything or not. Then I found at least 99% things you have already covered, and I'm familiar with that.
okay,
It
great.
will take only 1 or 2 weeks max to cover that book, line by line.
That's great. Thank you.
So,
Thank you so much.
so thanks a lot, Sri, and
Thank
hope to see
you
you again
very much.
very
Yeah,
soon.
let's meet up again.
Thank you, Shubham.
Okay. Thank you so much, Vasan. It was
Thank
amazing to
you.
have you guys. Okay.
Okay, bye.
Bye.
Bye,
Good
Sri.
night. Good night.
Thank you. Have a good night.
Yeah. Bye. Thank you so much.
Bye.